All right, so we're thinking about types of numbers today and classifying them, okay? So we're going to be classifying types of numbers. And as we do that, so if you open to that first page of your notes, as we do that, and have you set your water on the floor too. I want you to think from last year and write down as many types of numbers. You want to put them in a different order. Put this one on top. Okay. Each time for each. So write down as many different kinds of numbers as you can think of. Way on the top. Right where it says review. What kind of numbers are there? Okay, write down as many as you can think of. And the hint should be, yes, look further down on the paper, right? Or look up at the I can statement, right? But make sure you can tell me what those numbers, when you think about those, in the I can statements or down below on that next sheet of notes, the next page. What do those look like? What are some of those? How could you describe them in words? All right. So, kinds of numbers. Up at the top, you're going to see where it says the I can statements. I can classify real numbers as rational and irrational according to their definition, so we're going to be talking about that. I can state examples of both rational and irrational. We are going to be looking at that I can explain the sum of two rationals, how that could be rational, and the sum of two rationals, if I do the product, that's going to be rational. And if we are looking at these, all right, I'm just checking. For some reason, my one pen isn't working, so I was just trying to figure out. Okay. So, as we are looking at this, so as we look at this, these are our goals for kind of today, that I can explain the sum of a rational and irrational, how that could be irrational, and I can explain how the product. So we're going to really be looking at our products and sums. Okay. Sum is to do what operation? Raise your hand, please. Sum is to do what operation are we talking about? Tell me your first name again. Jake. What operation is sum? Addition. So here's where we're going to be adding two rational or irrational numbers, right, when we find the sum. And then our product, if we are looking at that, the product, Kylie, should be multiplication that we are looking at. Okay. So we're looking at multiplication, okay? So these special cases. So if we are looking at numbers, that next category down, and we're looking at what are all numbers. All numbers that we are taking a look at, we are going to have two different categories. This first one way over here, all by itself, is our imaginary numbers. You don't really have to worry about that till Algebra 2, okay? So please write that down as imaginary numbers. The next one is going to be our real numbers. And under real numbers, we have two categories. One has a bunch of them under, and one just has that one. The one that is totally by itself, besides our imaginary, does anyone remember the one that doesn't have anything else below it, if we are thinking about that? That is, Whitney? Zero? No, but it's a special name of numbers. Irrational. It's our irrational numbers. So here we're going to have irrational numbers. Irrational numbers. Last year you guys did like square root 2, right? You did things like pi. You did the square root of 20, right? Those are all irrational numbers. Never repeating, never ending decimal. Okay? Never repeating, never ending as a decimal. Okay? And cannot be written as a fraction. So when we go back to our other category over here, that was the most broad, is rational. So this is the most general at the top, right? So we're going from a very general topic up at the top, okay? So this is our most general or broad topic, going all the way down here, and when we get to the bottom of this, this is going to be our most specific one, okay? So this goes from general to specific. And when you look at this tree diagram, the nice thing about tree diagrams is everything below is part of the one above it, okay? So when I am thinking about that, my most specific category is called the natural numbers or counting. That's the most specific. It's the smallest group we like to think of, right? So I got 0, I got 1, 2, 3, 4, 5, 6, right? Actually, I don't have 0, right? I just have 1. So if I'm thinking natural, that's 1, 2, 3. Which one has 0? Anyone remember the name? It includes 0. Whole numbers. That's 0 and the counting numbers. So it's just like counting, only thing that includes 0. And then above the whole numbers is, these are our integers. That's the positive and negative, right? So it's 0. And if I was going to give a list of these, right, I could think of this as being 0, 1 and negative 1, right? 2 and negative 2. Our whole numbers are 0, 1, 2, right? And our counting ones are just thinking of 1, 2, 3. Could I have written 20 divided by 5? Is that a natural number? Yes. And rational numbers just mean it can be written as a fraction. We can write it as a fraction. So all of these numbers down below can all be written as fractions, correct? Every single one of them. Counting numbers, whole numbers, integers, and fractions all can be written as a fraction. And those are considered, when we look at those, the real numbers, okay? The other category in our real numbers is our irrational. All real numbers can be graphed on a number line. There is a point for every real number and every irrational number on our number line, okay? So, the definitions. You turn to that next page. Kind of a nice definition for imaginary numbers that are not real. It's actually when you have the square root of -1. When you get into Algebra 2, you work with that, and that's part of the imaginary, right? When we look at real numbers, as you are filling this in on the top of the next page, these definitions. Real numbers. A value that can be found on the number line. You're right. Okay, a number that can be found on the number line. Are irrational, decimal that never ends and never repeats. And if it helps you to think and put an example of one of those, you can do that, right? Number that never ends and never repeats. That's like our square root 2, our pi, our square root of 15. Does square root 4 fit in that category? No, because square root of 4 is 2. Rational. It can be written as a fraction. It's 2. It's actually a natural number. So when you think of our rational numbers, all decimals that end or repeat. I don't know if you remember last year converting the repeating decimals to fractions that you did in class. So all decimals that end or repeat, including all fractions. So the key thing, you see a fraction, you're going to always say rational, right? In your homework tonight, you're asked to identify what's rational, what's irrational. You see a fraction, rational, you're done, right? If it says get more specific with it than just rational, if it's a negative or positive whole number, you're going to tell me it's an integer, right? If it's a whole number, it goes from 0 up, and a counting number, 1, 2, 3. So those brackets, that's called set notation. We don't do a lot with set notation, but I'd like you to put the dots behind on both sides of that. That's telling you it continues on forever, right? Now, sometimes I will have people write the integers this way. They don't like to write it this way. They like to write it like 0, 1, negative 1, 2, negative 2. Something like that. Is that the same thing? Yes. Okay. These brackets tell us that this is a set of numbers or a specific group of numbers. They're kind of important, okay? So they use those brackets. You don't have to be perfect in writing those, but yes, put those down in your notes. Put those brackets there, okay? It's not a parenthesis. It's kind of a squiggly line, right? So if you put a parenthesis, that's different mathematics notation, okay? So I'm going to be kind of picky on this. So you can see why pi is saying to this number, this is our imaginary number, right? So he's telling it to get real, and he's telling pi be rational. One of my math friends, she and her husband, who was also a math teacher, and her son were in a badminton competition at the high school. I think it was down in Davies or so. And so that was their shirt. That was like their team name, be rational and irrational. One was rational and one was irrational. Be real. So. All right, so numbers. It says, thinking about these patterns, let's look at some. A rational plus a rational, like 4 plus 8. 4 plus 8 equals, is it going to be rational or irrational? Right now, what I want you to do is just put down what you think. Just like here, when we get these, I just want you to think, is it rational or irrational? Is this going to be rational or irrational? Okay? If you multiply those. And I would like you to just very quietly, you don't have to write anything, just talk to your shoulder partner. Okay? What do you think? You're going to say rational, irrational, for either one answer, right?
Irrational. If they're going to be 100%, it's always going to be rational, but if they think some of them can be.
All right, Abby, what do you got for when you add 4 and 8? What are you going to get? We'll go Abby, you. 12. So if we were going to put that down, what, Ben, would you tell us, rational or irrational?
Rational.
It's going to be rational, okay? Right? That is going to be rational. If I add any 2 fractions or any 2 rational numbers, I always get a rational number. Now, when I have 5 plus square root 3, that answer in simplest form is 5 plus square root 3. And since square root of 3 is irrational, our answer would be irrational, right? Since square root 3 is irrational, that is my answer, right? When I get down here and I am looking at, this answer is 9. We might write it this way in simplest form. We might not write that times, but it's 9 square root 5, right? This one we know, nice, it's negative 12. So the second one happens to be rational or irrational? Irrational. And the first one was rational when we are looking at that. Since these 4 situations are always true. Other combinations are not always true. And the question is, why is that the case? So right now, I want you to talk to your shoulder partner. Why do you think that is not the case? Why is this? These are always going to be true. Every time. Talk to your shoulder partner with why you think that could be. Okay? Meaning, if you had a rational, if you were doing something with 2 irrationals or something else, right? Okay, so talk to your shoulder partner with what you think.
So rational times rational is always true. No, seriously, it's irrational times irrational. Irrational is always irrational. No, but
someone have a case for us that they want to share that they think, oh, this isn't going to be true. Anyone want to think of something that you talked about? So like if we're thinking about irrational numbers, right? Irrational. And what if you do what with an irrational? Kylie, what do you think?
Add it to another irrational.
Okay, so if we add irrational plus another irrational.
It depends on what the numbers are. If you have the same square root, then it's whatever the number was.
So do we think like where this one you have a rational and irrational, you add, you get irrational. Rational plus rational is rational. Here it's rational. So we're not sure if this is going to be irrational, right?
It depends on the numbers.
Or rational, right? That's kind of what we're thinking. We're trying to figure out. Which kind of leads us to this next case. It says, can the sum of two irrationals be rational? If so, give an example. So I want you to write down some irrational numbers, and I want you to think of adding them. You can come up with whatever irrationals you would like, right? You know that irrational could be pi. It can be any of our square roots that are not perfect squares. So right now on your paper, what I want you to do is I want you to
Easiest
All right. Jacob, did you guys come up with something for the first one?
Yeah.
What?
Pi plus negative pi.
Pi plus negative pi equals 0. Do you agree? Okay. Do you have another one for the square root 3 then? So plus what? Plus a negative square root 3. That gives me 0, right? And,
8 square root 8 plus negative square root 8.
okay, is that making sense? That's rational, right? You can't add two different irrationals, but oh, how nice is this, right? That when we look at this, right? When we look at these two are all going to be opposites of here, and it gives us this nice rational number of 0. Okay? Now, so the sum of two irrational numbers, can it be rational? And we would answer this question then with a yes, right? The sum of two irrationals, can it be rational? Yes. But does it have to be rational? No, you could add two irrationals. So this would be kind of a sometimes, right? And these would be our ones that all equal nice rational numbers. But then sometimes rational, but most of the time it's going to be irrational, right? Most of the time when I add two irrationals, if I add square root 3 plus square root 6, that is equal to square root of 3 plus square root 6 simplified. It's that, right? It's two irrational numbers. And if I put them in my calculator, those are decimals that repeat and never end, it would come out. Now my calculator is going to stop it at some point and it's going to round it, but that would be right. So now thinking about that, what we just did up here, I want you now to write two irrational numbers and the product, we're multiplying them to get a rational. You don't want to get the same rational, right? You don't want to get 0. You want to get a different rational. Think what rational we might be trying to get when you multiply. It's really important to multiplication. By the way, does anyone know what 0 is in addition? It's called our what? Additive what? It's really important to addition. I can add it to any number and get what I started with, right? Anyone know what that's called? Math vocabulary? Owen.
Additive neutral or something
Additive,
like
no, Kylie, got it?
I want to say it's like a property or something.
It is. It's the additive identity. Make sure you write that in your notes. Additive identity. It's a really important one, okay, that we look at. Additive identity. And the one that you're going to get here is not the additive identity, but it has to do something with that word product. Okay? So right now, try and write out some multiplying ones. Some multiplying ones. Start with an irrational. I don't care if you want to start with our same irrational we started with before. Our square root 3. Our pi. Our square root 8. Maybe you don't want to use pi. I don't know. That's up to you. You don't have to use other irrationals. All right. Please talk to your shoulder partner and see if you know what is the rational number we're trying to get. It's really important to multiplication.
Trying to get one, but I can get one that's not.
We're trying to get a rational. You're using two irrationals to try and get irrationals.
Do they have to be different irrationals?
It just says two irrationals. Okay? It just says two irrationals. So the multiplicative identity, you know what number it is? Sanjay, it is 1. That's one number, but we wouldn't have to get that. Could it be, so that's our multiplicative identity. Could we get, if I take square root 3 times what to give me a rational number? And it's not going to be 1. Okay. Times square root 3 equals 3, right? If I have pi over, I might want to go with a, can I go 1 over pi? Could I do that? Yeah, is that going to work to give me 1? That's rational. Pi divided by pi is 1, right? Can I take square root 8 times something? What would you think multiplied by? I could go 1 over square root 8, or I could just go square root 8, right? So this one was equal to 1, this one is equal to 8, right? Because 8 times 8, square root of that is square root of 64, and square root of 64 is 8. And anytime you multiply those. So, in summary, what can we say? We have 4 types of problems that we looked at that are always true. All the other combination are sometimes. The reason this one is a sometimes, right, that this is sometimes true, we came up with some cases where it equals a rational, but most of you, if you thought of square root of 3 times square root of 9, that's going to give us the square root of 27, and that's still irrational, right? There's many that'll work, but what do you have to notice about those ones, right? So keeping that in mind. Now that next screen down, right now, give me a thumbs up when you have this written down so I know I can go down. This is the summary. You should have this written in your summary. And when this comes up, those of you that are a little slower writers, I will be putting these notes online. So I might not wait for you in class if I know we have to keep going and you're kind of just sitting there and you don't feel like writing down the notes. I'm going to assume that you're going to go online later and you're going to get them from the online notes, okay? If you're ever absent and you have an appointment period too, after this period, usually sometime during the day, I'll be posting the notes, okay? All right. So, you are asked, do not solve these. I want you to put an R for rational or an I for irrational behind each one. After you have gone down that first column, please check with your shoulder partner and see if you agree or disagree, and then do the second column. R or an I. Go. R for rational, I for irrational. After you've done the first column, I need to hear you talking to your shoulder partner and telling your answers and kind of why did you put that in a check. Don't solve it. Just put the R or the I. Talk. If you have not done the second column, quietly please, and do the second column if you have not done that. Are you in agreement so far? Rational, irrational, rational, rational, irrational. These two are both rationals. And the key thing is because this is really, right, 2 times 3. Square root 21. No, that's going to be negative 2 pi is how we can write that solution. 0.5 times square root 8, so we're going to be that, okay? Now, I would like you to turn to the very back of your notes, right behind the worksheets. We talked a little about some properties, but, okay, so that it has the answer keys, and then there's some blank pages, and I want you to do this on the back of that last answer page, which has 73 on the bottom, so on one side it's the answer page, and then this, okay? These are some of the properties of equality that I'm going to be asking you to use. And on this test and on your final, you have to tell the properties of equality. So today when you do your homework for half the questions, either the even or the odd on the part where you're solving, you need to tell me the property. Meaning if you're given this property, so please write down in your notes, addition and subtraction property of equality. Write that word down in your notes. This is on that blank page. And you can do it on the very back, but I would do it right on the back page of your last answer sheet. Okay? So, put properties of equality. You have addition and subtraction property of equality. And this is what the property says. You can add the same number or subtract the same number from both sides of an equation and get an equivalent equation. So, if I was writing it in my own words, I'm definitely putting first addition and subtraction property of equality. Now, when you do your homework, you can tell me either addition property of equality or subtraction property of equality, right? And all that means that when you solved it in your head, and you might have been able to do x minus 3 equals 2, but what you really did in your head was you were adding, by our addition property of equality, you added 3 to both sides. Okay? This is, in your textbook, this is lesson 2.1. Okay? So if you can't find this, or you don't go to the notes online, that's our first one, right? It just says you can add and subtract the same number from both sides of an equation. It's called the addition property of equality or subtraction property of equality. The next property, multiplication property of equality, and then we have division property of equality. And it's pretty much the same thing, right? You multiply on both sides of the equation by the same number. So they showed this example. X divided by 3 equals 2. They multiply by 3 on both sides. Why do we do that? We write the addition or the multiplication property of equality. Here, 5 times x, dividing both sides by 5. And I will often have someone say to me, but you know what? Couldn't I have said in this problem, 5 times x equals 20? Couldn't I say I'm going to multiply by 1/5? That's still, and so I would take either the multiplication or division property, right? Multiplying by a reciprocal is the same as dividing. Question.
Does it still would it still be equivalent if you did it with an inequality?
We'll talk about that. That comes up when we get there. Okay?
So we do all the problems, but we only have to do half of them.
You're going to do all of them, but half of them you have to give me the property. And we're going to do one in your homework so you can see. Okay? So these two properties, addition, subtraction, multiplication, division. Where are they in your notebooks? 2.1. Okay? So if you wanted to look in your textbook that you have, it's section 2.1. And you are going to find that we're jumping around a little at the beginning. Okay? So we're not going to look at solving these, but you can solve problems with reciprocals. And again, I'll have these notes up. If you have 4/5 times n equals 28, you'd multiply on both sides by 5/4, and we would put down multiplication property of equality. So what I want to look at is turn to your workbook, A1, number 23. And what I might suggest is that, you know, where the homework problem's starting there, that like maybe you put a paper clip or you just fold that page, right? You fold like this page so that you know this is where all your homework is starting in here, okay? So you have your workbook, your whole notebook, and now you're at that folded page. And I want you to look at number 20. We're going to do it for the evens. So for the evens, you need to write the property. So if I have x plus 7 equals negative 11.5. To solve that problem, what do you have to do? Subtract what from both sides? Subtract 7. I need you to write the subtraction property of a property right behind it. That's all you have to do. And you're going to finish solving it. And x is equal to negative 18.5. So let's look at one of our multiplication or division ones. Do I do 26 or 28? 26 or 28? 26, raise your hand. 28. Some of you don't care. I don't have to do either one. Doesn't matter to me. All right, we got a minute. This W over 8 could be written this way, right? We could think of this as equals, you can leave it as W over 8, or you can think of it as 1/8 times W, right? Same thing, right? W divided by 8 is the same as 1/8 times W, okay? So, you might here use multiplication property of equality because you're going to multiply both sides by 8, right? Would you use the same property here, multiplying both sides by 8? I probably would. So you're going to write your property. Multiplication, property of equality. Those 8's cancel. What is W equal to? Only the evens write the property, okay? You do want to do both pages of A1. If you didn't finish your directions, right, you just got a break today, right, with your graph. Make sure your directions, you can have someone else read them over to see if they make sense, okay? Make sure you have those with you.
Do we take the books?
Yep, take your textbook.
Did she take the